All right, hey Haley, this is example 3. We are on whatever this 4-1, increasing, decreasing, constant functions, that stuff. Okay. So here's the deal. They give us this function right here. Well, they don't give us the graph. They give us the equation, and we have to determine increasing, decreasing, that type of thing. Okay. So step number 1, very first thing that we do is what?
So I guess
find the derivative.
Get like 2 through.
Okay, let's do that. What's that derivative going to be?
Wait, what? Is derivative first?
The derivative of this guy.
12x to the third plus 12x squared minus 24x plus 0.
Plus 0. Yep, there he is. Okay. Second thing. Equals 0 to find, what do we call those things?
Critical.
Critical numbers. Where the critical things are. I take the derivative, set them equal to 0 to find where the critical places are. Okay? So let's do this. What can we do to this thing?
What can we do?
What can we do?
X out.
You can take an x out. You can take a 12x out, right?
Oh, yeah.
Leftover is x squared plus x minus 2. Hey, all right. I like it. This guy breaks down. He's a simple trinomial. What and what?
Plus, well, wait. Positive 2 minus.
Plus 2 minus 1. Awesome.
Oh, hey, you are.
Now, I'm just fast. Now what?
We're going to set them all equal to 0.
All equal to 0. Ugh.
So 0.
So
-2.
if I divide by 12, x is 0, right? X is negative 2, and x is positive 1. Holy crap. Ugh. All right, I'm going to go down here. I am running out of room. We're going to do our table down here. Woo! All right, how many critical numbers do we have?
Too many.
3, which means how many intervals are we going to have? 4. 1, 2, 3, 4. This is my heading section. Okay, so here's my intervals. And then I do my test point. Then I do f prime of x. Then I do my conclusion. Okay, so there is all my stuff.
What did we say the derivative was?
What?
12x to the third plus 12x squared.
Are we going to do the double one or not?
What? Oh, then do what?
The double derivative.
No, not on
Can
this
you
one.
scroll over to the derivative?
We don't want to know contour.
Okay.
But we don't need to.
Maybe here in a bit, we'll do it to that one, and then we'll skip another example. What?
Whoa.
Yay!
What you talking about?
Skipping examples. That's
Sister?
what we're talking
Oh.
about.
How did we get negative 2 and x equals 1? Setting in it equal to 0.
So you gotta break it down. Did you break it down? Okay, so we broke it down by taking a 12x out and then have that turn over.
Actually,
And we
I
split
don't
up
want to
the
do it to
turn
this
over.
one because the second derivative doesn't factor down nicely. Yeah. Like 36x squared plus 24x minus 24, that doesn't factor down nicely. So I don't want to do the second derivative to this problem. To find my critical numbers for the second derivative, I don't want to do that. Because the second derivative doesn't factor nicely. Okay. So,
Okay.
okay. Alright,
Can
there
you
you
scroll
go.
up
There's
a
the
little
table.
bit? I need the box to go away. You have a weird box thing. It's always in my way.
I'm sorry.
Every time. I just, yeah. Or critical numbers.
Alright, if I slap my critical numbers onto a number line, I have -2, I have 0, and I have 1. Alright, so let's do our test intervals. Let's write our intervals down.
Uh-oh,
Eli?
Sorry.
Are you with us?
In physics.
Yep.
Okay.
On my chair, and he like kept.
This interval is going negative infinity to -2.
Like, oh boy.
The next one is going from what to what?
I don't know.
-2 to 0.
0
Then
to 1 and 1 to infinity.
0 to 1, then
1 to.
1 to infinity. Perfect. Let's pick some test points.
You ready?
Wait a second. How
I need a number from negative infinity to -2.
If we didn't have a graph, how would we know that?
Negative.
What are you talking about?
That's what we're doing. We're
Because
doing
it's
it
our
without
critical
a graph
numbers,
right now.
Jay.
Negative 4.
I'm not even going off of the graph. My critical numbers were 0, negative 2, and 1. So I just put them on a number line and I said, you don't have to put them on a number line, but I'm just saying my intervals. So something's happening on the left side of negative 2, then something's happening between negative 2 and 0. I just put them in order and making my intervals.
I got a
Yeah?
little lost there.
That's okay. That's okay. Ask. If you get lost, ask. There's a lot of steps to this. And if you get lost on your first step, you're really in big trouble. So
We're
please
gonna
ask.
plug in
Please ask.
-3.
We're going to plug in negative 3.
We're gonna plug in -1.
Negative 1.
0.5.
0.5. Yuck.
And 2.
And 2. Sure. Okay, we have no choice. The middle one, or the third one's got to be 0.5 or something like that, right?
Okay.
Now we plug it into where?
Say derivative.
The derivative, which is that 12. Actually, you know what? Here's what I'm going to do. I'm going to do. This is a strategy to cheat.
You guys shouldn't have done that.
This right here is this right here is technically the second derivative, or the first derivative, but just broken down, right?
Indeed.
He is easier to plug into, and I'll show you why. 12x times x plus 2 times x minus 1. Yeah?
Yeah.
Okay, I'm going to show you how this is easier to cheat. Okay? That's my second derivative, but he's factored down. We're going to plug numbers into that guy. All right, you ready?
How are we cheating?
We don't care what the number is, true? We only care whether it's positive or negative, okay? So here's the deal. If I plug negative 3 in to here, 12 times negative 3 will be a negative number. Times, if I plug negative 3 in here, negative 3 plus 2 is we're not even doing math. Yep.
Yeah.
Is a negative number, right? If I plug negative 3 into here, it is a
Negative.
negative number. 3 negatives make a
Negative.
negative. So conclusion, he is
Negative.
negative. He's decreasing at that point. Yeah? We don't care what the number is, right? We don't care. We're totally cheating. Kinda. Now we're plugging negative 1 in, all right? So if I plug negative 1 into 12 times negative 1.
Negative.
Negative. Negative 1 plus 2. Positive. Negative 1 minus 1.
Negative.
Negative. So that is a...
Times negative is a positive plus a positive is a positive.
So he is
Increase.
increasing then. We don't care about the number. We just care about whether it's positive or
I think
negative.
I added
Wait,
another
what?
column. Oops.
Oh, that's what I did. Okay.
Okay, 0.5 if I plug him in. 12 times 0.5 is
Negative.
positive. I don't care what it is. 0.5 plus 2 is positive. 0.5 minus 1,
Negative.
negative. That makes him
Negative.
negative, so he is decreasing. Okay, last one, plug in 2. 2 times 12 is positive. 2 plus 2 is
Positive.
positive. 2 minus 1 is
Positive.
positive. So the whole thing is
Increase.
positive. The whole thing is increasing. Cool.
So increasing and decreasing.
So we're still on part A actually, but I flooded into B because this takes a little bit of time.
Yeah.
Okay. So I'm going to hop back up to A because I have room up here. They want me to write where he is increasing and where he is decreasing. So where is he increasing?
Negative 2 to 0.
Negative 2 to 0 right here. He's increasing.
Union.
Union
1
with?
infinity.
1 to infinity. Yeah? Now, is that true? Is he increasing from negative 2 to 0 and from 1 to infinity? Yeah, that's what part B is saying. Use the theorem to determine whether your conjecture is correct, blah, 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 all that good stuff. Okay. D says decreasing,
Check makes no sense.
and he is from negative infinity to negative 2, unioned
That
with
makes sense.
0 to 1.
Hard.
There you go.
Calc is hard, but it makes sense. No, it doesn't. Once you
I don't feel like it's
understand
hard.
what's going on.
It's a lot, and it's like organization is more than the math knowledge of it.
You know how I
Right?
said that I just told you this. You know how I said that I like trade calc?
No.
Change my
No,
mind.
no, no, no.
Okay. It goes back and forth. It will. Okay.
Trade is just
All right. I'm not going to get into this, but for concavity, you can look at these diagrams if you want to. When you're talking about concave up, your slopes, if you're concave up, your slopes are increasing. So the derivative of the derivative is increasing if it's concave up, which means your second derivative is positive when he's concave up. The derivative of the increasingness of the The slopes are increasing. So the derivative of the derivative is positive. That means it's concave up. Okay? If your second derivative
Is negative.
is negative, derivative is negative, that means it's concave down. So the slopes are decreasing.
I'm glad that
It's concave down.
they're not opposites. Like that would bother
There
me.
is one thing that's opposite. Well, we'll get to that later.
But that's
We'll get to
first
that later.
derivative, isn't it?
Yep. What? So for now, if it's plus, it's increasing. If it's plus, it's concave up. If it's minus, it's decreasing. If it's minus, it's concave down. Okay? One is for first derivative, one is for second derivative.
I thought you said that the first derivative was a positive, then it was a concave down.
So here's how this works.
Oh.
First derivative, if you want a like little flow chart. First derivative, let's do positive and negative. This is my two-way frequency table. My second derivative.
No, this is the rate. This is big T,
What?
little t, big T, little t. This is where we cross genes and
No,
stuff.
no. This is a two-way frequency table. This is a contingency table. If your first derivative is positive, it's increasing. If your first derivative is negative, it's decreasing. If your second derivative is positive, it's concave up. If your second derivative is negative, it's concave down.
Mendel.
That's what these things tell you.
The Punnett square?
That boy.
It's not a Punnett square.
We're not Punnett
That's what we
square.
said.
This
That's
is a
what we
two-way
said.
frequency table.
That is no Punnett square.
That is a Punnett square.
No, there's no littles.
Sure.
Okay, if we took
I
the
like
plus and the
genetics.
minus
Genetics
and the
and
first
biology is
derivative and
fun
the second
going
derivative, and we put t's in there.
Except like
It's a
I'm sure it
Punnett
gets 10
square.
times
Sure.
more complicated than structure rows, but you know.
Okay, good? Happy with that?
Nope.
All right,
The cat look off.
we'll do a thing.
I'm not ready yet.
Where am I at? Right here.
Sorry. I always drink my
Are these
water.
just for
I'm
polynomials?
really sad. I don't have a-
Nope, I bet you we do some more.
I
Okay,
really need it.
ready, set, go.
No.
Example 5. Here's our function. Okay, now we are no longer, for this problem, we're no longer looking at increasing, decreasing. So we're not going to worry about the increasing, decreasing stuff. We are just, oh no, wait. No, we are increasing, decreasing, concave up, concave down. Poo.
You lie.
All right, I lied. I'm sorry. Okay. All right. Here we go. Increasing, decreasing. We got to do the first derivative. I'm going to try to make this as clear as it can possibly be. Then I'm going to do my second derivative. Okay, then I'm going to do my like big table thing over here. Like huge table. Okay? All right, they give us a nice function to start with, all right? So this guy, let's take his first derivative. What's the first derivative?
3x squared minus 3 minus 6x.
3x squared minus 6x?
Yep.
Yeah. Okay, that's my first derivative. I'm going to set it equal to 0.
Take out the 3x.
Let's take out a 3x, and left over is
Minus 6.
x minus 2.
2.
Okay, so there's that. If I set the 3x equal to 0, x equals 0. If I set the x minus 2 equal to 0, x equals 2. Okay, those are called
Critical number.
critical numbers.
I hate critical numbers. They're dumb.
Yeah. Well, just wait. Stats, we were doing critical numbers as well, but those were Z's
and in trig.
and in trig.
Stats, calc, and trig.
Because they're critical. They're importantly critical. All right, now.
Except Josie was bringing up calc and trig yesterday. That was Josie. We can't overlap.
Okay.
They
Now,
already
before we make our table, we've got to find our critical numbers from the second derivative. Okay? We got to find our critical numbers from the second derivative. So, if this is my first derivative, I'm going to find my second derivative.
6x minus 6.
X equals 1.
6x minus 6 equals 0. So, if I add the 6 over, 6x equals 6x equals 1. That is also a critical number.
I know.
Okay, so now we have 3 critical numbers,
What's wrong with
which
it?
means
So if we weren't, I don't understand. The last one
I'll show you.
we excluded the second derivative. So how can we just add in another critical number?
That's a
What do you mean? Because on the last one we weren't looking for concave up, concave down.
I know, but why?
Now we are.
Now?
That makes sense.
Because they asked for it.
So why can't we just add it in there?
To the other one?
Like we could have, but we didn't.
We could have, but I mentally in my head, I took the derivative of this guy, and he was, if you really want to know, 36x squared plus 24x minus 24, and his, like that to factor down, does not come out nicely. And he would have been a decimal. And I didn't want to have that be your first experience with concave up, concave down. So I said, let's not do that for this one, right? Like we could have added to this table and done concavity.
But I just don't understand why we can.
What?
Just because it's asking for it, we can just be like, oh.
What do you mean?
If it asks for it, we do the second derivative. If it doesn't ask, we don't have to do it.
Here was just asking for increasing, decreasing.
So how is it not? How is the decimal not a critical number then?
It will be.
So why?
I just didn't want to do it because it was ugly.
I know, but it's, okay.
So he has concavity. He's concave up, concave down at different places. I just didn't want to do it because those places would have been really ugly places. And I don't want to do that one first. Does that make sense?
I get that.
Okay.
I get that.
Okay.
I just don't. I don't know.
Okay. So let's fill in the table. We have 3 critical numbers. If I put them in order, my critical numbers go 0, 1, and 2. Yeah?
No, it goes
Gross.
2 and 1. Oh, wait.
0, 1, and 2. If I put them in order.
I don't have a negative 2.
I don't know. 0, 1, and 2. So I have 4 test intervals.
2, 1, 3, 4.
7, 30. No, because I thought the constant.
I meant 0, 1 because I thought the
Okay.
was negative. Okay.
All right, ready? So my intervals. Let's go our intervals.
Negative infinity to 0.
Negative infinity to 0.
0 to 2. Or 1 to 2.
0 to 1. 1 to 2. 2 to infinity. Okay, these are my headings. Okay, I'm going to pick a test point. And then I'm going to do f prime
Negative 1.
of x. I'm going to do f double prime of x.
0.1.
And then I'm going to do my conclusion down here.
1.
Okay?
You're writing so fast.
I am writing so fast.
That sounds horrible.
What? My
Does
cough?
that hurt?
Yes. It really hurts. It's really icky. It like hurts my ribs around back. Like my back hurts. Right here. I have a cramp on my back.
It's her external all week.
So did you bring it?
My what?
I thought I was supposed to be that clear. Or is it your lap?
Alright. What test point do you want? Negative infinity to 0.
No. What's it called? Trap. Because your trap goes like
Negative
all the way
2?
down here.
I'm gonna go negative 1. Can we go negative 1 instead?
I guess.
Negative 1?
Wait, yeah. Where is it on?
Hey,
That's
like,
a trap.
like right there.
It could be beneath your
Negative
your
1.5,
side.
1.5.
Negative 0.5.
Yeah.
But I don't think.
Positive 0.5 and 3.
Wait, it's not negative.
It's negative.
It's 0.5 and
I can't math. That's exactly what you said, and I wrote the wrong thing still.
I was like, what?
1.5. I'm just can't math. And 3. Okay, there we go. I'm gonna write my first derivative down over here, and my first derivative, I'm gonna do the cheaty cheat thing. Can we cheaty cheat?
Okay. Oh, I meant that.
3x times x. What is it? X plus 2. X minus 2. Okay. There's my cheaty cheat
They're
thing.
too busy yelling at each other, and they're sitting. right
My
next to
second
each
derivative is
other.
6x minus 6.
You guys are really loud.
We're not yelling.
All right, there we go. There's my first derivative, second derivative. Let's plug them in. Negative 1 times 3 is negative. Negative 1 minus 2 is negative. So he is positive, which means he is increasing.
Whoa. I wrote on the wrong one. Where are we writing increasing?
Down on the conclusion thing.
Conclusion.
Conclusion.
Included.
All right, 0.5 times 3 is positive. 0.5 minus 2 is negative, which means he is a minus. So that means he is decreasing.
What?
Okay.
Don't we have to use the second derivative to?
No,
We're
no.
ignoring it right now.
Second derivative is concave.
You also said it like a robot. You were like,
Just wait.
included.
Okay. 1.5 times 3 is positive. 1.5 minus 2, negative. So he is
Decreasing.
negative. He is decreasing again. Wait a second. Why do we have? Hold up. Hold up. Hold up. Hold up. Just wait a minute. Look at this. Ready? Everybody look. Shh. Everybody look. No. Shh. Everybody look. I know you know why.
I know why too.
Why do we have 2 decreasings in a row?
It's going like this.
Concavity.
1 was not a critical number for first derivative. That's not where he's going to change from increasing to decreasing at 1, right? 1 was not in my list over here. So of course he's going to keep the same, right? Duh. Now, the deal here is when we go to do second derivative, listen to this. When we go to do second derivative, this was my only critical number for second derivative, which means that these are probably going to be the same. And these are going to be the same because this is where he switches derivative. Or switches, like, whatever, concavity, right?
Switches derivative?
Not derivative. Switches concavity.
No. What did you?
Because that was my only critical number. All right, let's move on.
No, what did you say that one time? You said a sentence, but it was like the definition of what you said. It was like,
I don't know.
I don't